Okay, we're going to look at trig identities now. First, we're going to look at the definition that we're going to use for our trig identities in this course. So the definition is an identity is an equation that is true for all values of the variable that works or is defined for both sides of the equation. That is the largest domain that is common for both sides. Now, this may not make sense, but what we're not looking at for trig identities is restrictions. Okay, so for example, we could write that 1 equals x over x. This is an identity for our purposes. We don't have to write that it's 1 comma x cannot equal 0, because the domain that's common to both sides is, well, x equals 0 works, everything works on this side, but x does not work if x equals 0 here, so we assume that x can't equal 0 for the whole thing. Okay. Another one would be x equals x squared over x. Okay, this is an identity. So what we've got here is x cannot equal 0 on this side, so it's not part of the domain for the whole thing, so we call this an identity. It is a true statement for all x in the domain of the whole thing. So those are two non-trig examples, and I'm going to give another non-trig example, which is just basic difference of squares. So x squared minus y squared equals x minus y, x plus y. So that is true for all values of x and y, no matter what they are, and it gives you a difference of squares. So it's not true for just some values, it's true for all values of x and y. Something that is not an identity, so not an identity, okay, would be something like c squared equals a squared plus b squared. So that's not an identity because it's not true for all values that you could put in for a, b, or c. This is only true if you have a right triangle. Okay, so this is not an identity. Now, we're going to look at some trig identities. Okay, so now for the trig ones, so this is a non-identity. Anything that's only true for specific cases, okay, is not an identity. For example, 2x equals x minus 3. That is not an identity. Okay, because if I chose x equal to 25, 2 times 25 is 50, and 25 minus 3 is not 50. This is solvable. It's true for one value of x, but it's not true in general. Okay, so that's also a non-identity. So one of the basic trig identities that we'll look at is, or the first one is, so let's call it identity 1. Tan theta equals sine theta over cos theta. Okay, so is this true? Well, we need to look at it. So we're going to look at the left side and the right side. So just like when you're doing a check for equations, you want to check the left side and the right side of the equation. Okay, so we're going to check the left side first. So left side equals tan theta, and we know the definition of that is y over x. Okay, so that's the left side. Now we're going to look at the right side. Okay, and that's sine theta over cos theta, and that equals, well, sine theta is y over r, and cos theta is x over r. So we can change that division to a multiplication. Y over r times r over x. The r's cancel out, and you get y over x. And that happens to equal the left side. So that equals the left side. So therefore, tan theta equals sine theta over cos theta, no matter what theta is. Okay? So that's our first identity. First true statement about trig. Okay? Now, we're going to look on to what else we could get from that after. But now we're going to look at second identity. Okay. So identity 2, this one's going to be called the Pythagorean identity. Okay, because it uses a Pythagorean theorem, basically. So this one is sine squared theta plus cos squared theta equals 1. Now, sine squared theta equals sine of theta all squared. Okay, just so you're clear on that. Now, it's not true if it's sine negative 1. If it's sine negative 1 in here, that means inverse sine. So it's kind of a bad notation, but if you understand it, we can make it work. Okay, so we're going to look at this one. We're going to look at the left side first, because the right side is just 1, so it's kind of easy to figure out. So the left side equals sine squared theta plus cos squared theta, and sine theta equals y over r, so I'm going to put y over r, and then I'm going to square it. And then cos theta is x over r, and I'm going to square that. Okay, so now I'm going to distribute in the squared here. So we got y squared over r squared plus x squared over r squared. We have a common denominator, so we're going to do y squared plus x squared over r squared. Now, if you recall that when we look at the relationship between x, y, and r, well, in Cartesian plane, if we look at this circle, okay, there's r, there's x, y, and from Pythagorean theorem, okay, so x, y, x squared plus y squared equals r squared. So x squared plus y squared equals r squared. So I can change that top line to r squared. And that equals 1. And that equals the right side of the equation. Okay? So now we've proven that one, so therefore sine squared theta plus cos squared theta equals 1. Okay, that's our second identity. Okay, so these are our two main identities. Tan theta equals sine theta over cos theta, and sine squared theta plus cos squared theta equals 1. And we can manipulate these a little bit so that we have some more. Okay, so from tan theta equals sine theta over cos theta, we get an alternate one where we could bring up the cos theta. Okay, so sine theta equals tan theta cos theta. So there's one. Okay. Also, I could solve for cos theta by bringing the cos theta up and the tan theta down. So cos theta equals sine theta over tan theta. Okay, so those are two others that you can get from that one. Now from the Pythagorean identity, okay, and you got to be careful that you write in the thetas. sine squared plus cos squared equals 1 is maybe the way you say it, but you must write the theta in, or the angle in. Otherwise, it's just a weird statement. That's like saying square root plus square root equals 7, which is not correct. Okay, so from this, we could bring the cos squared over. So we've got sine squared theta equals 1 minus cos squared theta. And that one's interesting because you can then factor it. Okay, so this is 1. You could factor that because it's a difference of squares. So 1 minus cos theta, 1 plus cos theta. Okay, or cos squared theta equals 1 minus sine squared theta. Again, is 1 minus sine theta, 1 plus sine theta. Okay, and this will become interesting later on because we'll be looking at proofs where you might have a 1 plus sine theta in it and you got to manipulate it. So if you multiply the top and bottom by 1 plus sine theta, then you get this identity here and you can change it to that. Okay, so these are also identities that we can use. But we could also prove them. So the way I came up with these is not necessarily how you prove them. They seem to be somewhat obvious, but it's not how you prove them. Okay, so if I ask you to prove one of these identities, so cos squared equals 1 minus sine squared, this is how it would go. So this is a basic proof of how we're going to work now. So I proved the first two identities, the Pythagorean and the tan theta equals sine theta over cos theta, from first principles is what it's called. So from the x, y, and r, so that's from first principles. Now we're not going to use that for most of our proofs. We're going to jump right into knowing these two proofs and going from there. So if I said prove, let's say sine theta equals tan theta cos theta. So prove that, then this would be the proof. Okay, so I'm going to start from the right side because it's more complicated. So right side equals tan theta cos theta. And we know from the main identity that tan theta equals sine theta over cos theta. So we're going to take that and replace it with sine theta over cos theta times cos theta. We're not moving something from one side to the other anymore. We did that to see these other ones, but we're not doing that anymore. Okay? So we know that this is identity, but we're just proving it now. So sine theta over cos theta times cos theta, the cos thetas cancel out. And we get sine theta, which equals the left side. Okay? So therefore, sine theta equals tan theta times cos theta. Okay? And we'll do one more. Let's do prove. Sine squared theta equals 1 minus cos squared theta. So I'm going to start from the right side here. So let's do the 1, so the right side equals 1 minus cos squared theta. I'm going to replace the 1 with what we had up here, which was sine squared plus cos squared theta. So sine squared theta plus cos squared theta minus cos squared theta. Okay, those go away, so you end up with sine squared theta, which equals left side, and therefore you can make that statement again. Okay, and that's it for this. I'll do another video of some more complex trig proofs.